topic is system of equations. We have n unknowns and m equations. This is the m equations with the n unknowns. a11 x1 plus a12 x2 plus etc. a1 and xn equal to b1 is one equation. a21 x1 plus a22 x2 plus etc. a2n xn equal to b2 etc. am1 x1 plus am2 x2 plus etc. amn xn equal to bn. These are the m. This is the first equation. This is the second equation. This next is third equation, etc. We have m equations because here m1. So we have m equations and x1, x2, etc. xn, n unknowns. So here we have m equations and n unknowns. These m equations and n unknowns can be rewrite as matrix form. That matrix form is A equal to a11, a12, etc. a1n, a21, a22, etc. a2n, am1, am2, etc. amn. This is the first matrix from these equations. Next is x equal to x1, x2, etc. xn. Next matrix is b1, b2, etc. bm. So we construct three matrices from this equation. So m equations, we take all coefficients. We have n variables. So each variable have a coefficient. So each coefficients we write down in the matrix form. So first equation we have a11, a12, etc. a1n. Coefficients of x1 is a11, coefficient of x2 is a12, etc. Coefficient of xn is a1n. So that is write down the first row. Similarly, second equation coefficients a21, a22, etc. a2n respectively. So write down second row. We can write down second row. Similarly proceeding, we can write down the mth row is mth equation's coefficient am1, am2, etc. amn. So we got here n rows and m rows and n columns. So we got coefficient matrix, m cross n coefficient matrix. This matrix is called coefficient matrix. So we have m equations and n unknowns. So we got m cross n coefficient matrix. Then we write down the other matrix, variable matrix. This matrix is called variable matrix. Variable matrix we write down, take out all variables of above equations. We have x1, x2, etc. xn variables. So each variables we take and write down a matrix form, column matrix form. So x1, x2, etc. xn. This matrix is called variable matrix. Then we write down the constant b1, b2, etc. bn. We take out these equations, from this equation to take out constants b1, b2, etc. bn. We write down the matrix form, that is b1, b2, etc. bm in the column matrix. This is called constant matrix. So this equation is n rows and one column. This is also m rows and one column. So we have m equations and n unknowns. We write down these equations in the matrix form. Take out the coefficients and write down the matrix form. That is a coefficient matrix. Take out the variables, write down the matrix form. That is a variable matrix. And we take constant matrix, write down the matrix form. That is called a constant matrix. So in this matrix, we can write down the above equation in this form. Ax equal to B. A is an m cross n matrix. S is an n cross 1 matrix. B is an m cross 1 matrix. So A is a coefficient matrix multiplied by variable matrix. We got constant matrix. So we can write down the above equation in this form. Ax equal to B. A is a coefficient matrix, X is a variable matrix, and B is a constant matrix. So above system of equation we can write down the form Ax equal to B. Here A is a matrix, X is a matrix, B is a matrix. Here we can write X is a matrix, x1, x2, etc. xn. X is a matrix which is variable matrix. So, any vector x which satisfies in this equation Ax equal to B is called solution matrix. So, x is a variable matrix. So, we need to find out that variables. So, any vector satisfies in this equation, such vector is called solution matrix. So the X is a vector, a variable matrix which is a column vectors x1, x2, etc. xn. Which these x1, x2, etc. xn, these n vectors satisfies our above m equations. That we have variable matrix X. That variable matrix is a column vector which has a vectors x1, x2, etc. xn. That n vectors satisfies m equations. That matrix is called solution matrix. So we have m equations and n unknowns. A11 x1, A12 x2 plus etc. A1n xn. Similarly A21 x1 etc. A2n xn. So follows AM1 x1 etc. AMN xn. This B1, B2 etc. BM. So these m equations and n unknowns we can write down the form Ax equal to B. When these BIs, all BIs are 0, that means B equal to 0. For all BI 0 means we got a constant matrix C0, 0, 0. Then we can say B equal to 0. The system is said to be homogeneous system. System is said to be homogeneous system. For all one of the BI not equal to 0 for some I. That means B is not equal to 0. Such cases, constant matrix is not equal to 0, then we can say system is non-homogeneous. we write down m equations and n unknowns, we can write down the matrix form, that is Ax equal to B. That B is equal to 0, then we can say homogeneous system. B not equal to 0, then we can say non-homogeneous system. If B equal to 0 means all constants are B1, B2, etc. Bm's are 0. Then we can say homogeneous. So B, capital B not equal to 0 means sum of the Bi not equal to 0. Sum of the small Bi not equal to 0. Then we can say such system is non-homogeneous system. A set of values x1, x2, etc. xn. These n unknowns satisfies m equations. This x1, x2, etc. xn is called set of solutions of simultaneous equations. So we have m equations and n unknowns. So we need to find a solution. So we got x1, x2, etc. xn. So these unknowns we got means these unknowns value we got means that values is solution set of simultaneous m equations. So we have m equations and n unknowns. So we got a solution. So we can say these m equations may be a solution or may not be. Always exist, that is not guaranteed. Sometimes it is exist, solution exist, or sometimes not exist. So we can say a linear system may have solution exist or solution not exist. Solution exist means we got a solution. So that solution can be unique or more than one solutions. So solution exist means have solution. So solution unique means one solution or more than solution. More than one solution. More than one solution means infinite solution. Solution not exist means no solution. So we have m equations and n unknowns. So solutions have three possibilities. One is unique solution. Next is infinitely many solutions. Third one is no solution. So one of the three possibilities are possible. So we have m equations and n unknowns means unique solution or infinite solution or no solution. These three possibilities are exist. Solution system have one solution or more than solution means we can say system is consistent. If system have one or more than solution, then system is consistent. Otherwise means if system has no solution, no solution. Such a system is called inconsistent. So M equations and N unknowns means solutions can possible three ways. No solution, one solution or infinite solution. System have solution, one or infinite. Next important term is augmented matrix. In the case of non-homogeneous linear equation, non-homogeneous linear equation. Non-homogeneous linear equation means AX equal to B. We have to verify that if it is consistent or not. So we need to verify the system, non-homogeneous system is consistent or not. To test the consistency of the system, require a new matrix. That matrix is called augmented matrix. We need to test consistency. So, we have to construct a new matrix for testing consistency. Such matrix is called augmented matrix. So I will say the actual definition of augmented matrix. The matrix, augmented matrix denoted by A by B. So A by B, which is the augmented matrix is obtained by placing the constant column matrix B to the right side of A. That means we have A11 x1 plus etc. A1 and xn equal to B1. A21 x1 plus A2n xn equal to B2, etc. an1 x1 etc. ann xn equal to Bn. We have am1 bm m. We have m equations and n unknowns. So we can construct a column, the coefficient matrix A11 etc. A1n, A21 etc. A2n etc. am1 etc. amn. That's a coefficient matrix. And constant matrix B is B1, B2 etc. Bm. So in this constant matrix we place its right side of this matrix. That means A11, A12 etc. A1n, amn, am1, B1, B2 etc. Bm. So this matrix is called augmented matrix. We placed an extra column in the coefficient matrix. Such matrix is called augmented matrix. Denoted by, okay. So by using augmented matrix, we can check the matrix is consistent or not. So I will say one theorem related to consistency. A linear equation or linear system of equation Ax equal to B is consistent if and only if, this means if and only if coefficient matrix A and augmented matrix A by B have a same rank. So a relation related to augmented matrix. A linear equation Ax equal to B is consistent coefficient matrix if and only if coefficient matrix A and augmented matrix A by B have same rank. Means we need to find the coefficient rank of coefficient matrix. First we need to find rank of coefficient matrix. Next we need to find rank of augmented matrix. These two matrix rank is same. Then we can say our system of equations is consistent.